Now, rotation. Rotation, first I have a typo. This should be counterclockwise, so cross that out, and that's counterclockwise. To rotate any point, A, B, or X, Y, whatever you want to call it, counterclockwise on a graph, counterclockwise positive, correct. We're only going to rotate three ways. We're going to rotate either 90 degrees, 180 degrees, or 270 degrees. 90 degrees is a quarter turn, 180 degrees is a half turn, 270 degrees is 3/4 of a turn. So here's our rules. It says it gets kind of confusing, you know, to do these rules. So here's what I want us to do. You notice AB, what happens is there's some switching in places and there's some sign changing. Let's do all of the sign changing first. So isn't it true that we need to change Y sign? The Y value changed. B is the Y value. B is the change Y sign, then switch places. That's the order that seems to be better for our brains. So change Y sign first, then switch places. This, to rotate 180 degrees, is just change both signs. Change both signs. And this guy is change X's sign, then switch places. Cool. Let's do this. This is point 715 under a rotation of 180 degrees. Change both signs. It would rotate to -7, -15. That would be the new image. 90 degrees, change Y sign, then switch places. And rotate to 270 degrees, change X's sign, then switch places. So that's what we'd get when we do those. Let's actually do some on a graph. It says rotate this guy 90 degrees. Here I've got my rules written down again here. You have them on your paper, but I got my rules right there. So first thing you got to figure out is like where these original points are, A, B, C, D, the pre-images are. So where's A at? A is at 1, 2, 3, 1, 2, the point 3, 2. A is at 3, 2. So you got to figure that out. Figure out where B's at. B's at 1, 2, 3, 4, 5, -2. And do that for C and D. Figure out where those points are at. And D's at -1, -2. So got to figure out where your original guys are at. Now, to rotate the figure 90 degrees, you want to change Y sign and then switch places. So how about -2, 3, 2, 5, 1, 2, and 2, -1. There, I've used my rule to do this. Now let's graph this thing. And this should look like it made a quarter turn counterclockwise, right? So it's going that way, and it'll just turn a quarter. Around what point? Around the origin. This is like the center of rotation. So it's like we're rotating that dude around the origin. So get rid of that point real quick here. A prime's at -2, 3. 1, 2, 3. B prime's at 2, 5. 1, 2, 1, 2, 3, 4, 5. C prime's at 1, 2. D prime's at 2, -1. And then connected them in the right order. Make sure you label them as you go. A to B. How about blue? A to B. B to C prime. C to D prime. That thing just turned a quarter of a turn compared to all the way around, a quarter of a turn counterclockwise. Go again. You notice in this problem, this picture right here, I used the same graph again, right? The same graph from 4 to 5. So, like, you already have the A, B, and C, D values written down. Oh, notice on your paper, I don't think that they had them. You should have put in those, right? Write them A equals B equals C equals D equals. It makes life so much easier. So, you should have those already. Just figure out where your new primes is by using the rule for rotating 180 degrees by just changing both signs. So, when you do that, I'll pause the video for you, or you should pause the video, I should say, and do that. And you should have got that for an answer. Check them real quick and graph them. And it looks like that thing rotated a half turn around the origin. So rotate 180 degrees counterclockwise. And then the last two, figure out where your original points are first, A, B, C, D, and E. It's the same graph on both of them, so just over here on your left margin, which I didn't have room for. Then use your rules. Go ahead and do both of them. Just pause the video, do both of them. When you're done, it should have looked like so. So that, my friends, is it. How to rotate stuff on a graph. Some rules to remember. And if you have any questions, please see me. Have a good one. And the last thing of the day is a dilation. For those who have been to the eye doctor, I think you understand this better, because when they put those drops in your eyes to dilate your pupils, they are making them larger, right? They are making your pupils bigger, so that way the eye doctor can see in there easier. That is why you are blinded when you go out in the sun after that, because there's more light coming into your eyes and you can't handle that, right? So a dilation is a size change. So preview. Do you think these are going to be congruent when we graph them? No, there is a size change. So first, let's graph the OG. Let's graph JKP, which is still called the pre-image. J is at 2,4. K is at 4,4, and P is at 3,2. And I picked a little too big of a graph for this because that's a tiny little guy. Sorry that he's so tiny. That is called the pre-image. That's what they gave us. They ask us to find the image next. They give us a scale factor. They use R for the word ratio, right? There's like a ratio of 2 in this case. All that means is take every number in your ordered pair times that guy. We're going to take them times 2. If you need to use a calculator, great. If not, no big deal, but let's do J prime. The X has to be taken times 2, so wouldn't that become a 4? And then the Y has to be taken times 2, an 8. Do you see where I got 4, 8 from? If J is at 2, 4, and it's supposed to get times 2, it would go to 4, 8. See if you can figure out where K prime would be. Check it with mine. And see if you can figure out where P prime should be. And before we graph this, I have a question for you. If you take something times 2, what should happen to it? Get bigger, get smaller, or stay the same size? So this dilation is going to make it bigger because R was bigger than 1. Does that sound all right? R was bigger than 1. So graph this guy. We should get a bigger picture on this one. So 4, 8 is where J prime would be. K prime is at 8, 8. And 6, 4 is where P prime is. And when we do the dilations a different way, without a graph, we'll realize that they have to be like dilated around a certain point. We are dilating these guys around the origin. Like if I was to connect this together with a red line right here, the distance from here to here and there to there is twice as much. The pink one is twice as long as the orange one in that one. They're also 2 times bigger. Right? So let's do that one more time, man. Let's draw the OG. And what do you think? Should this guy, if the ratio is 1.5, get bigger, smaller, or stay the same size? It'll still get bigger. Right? So graph the original. So this guy's got a scale factor or a ratio of 1.5. It should get bigger. We just take each one of these guys times 1.5. So -2 times 1.5. And that still came out pretty nice to -3 in that case. So just do that. Looks like they keep using 2's or -2's, so they're always going to turn into 3's or -3's. And then graph that guy. And he'll be an interesting little picture. He got 1.5 times bigger. And it's totally okay if you don't understand this answer. But once you get him graphed, how come on this one, the original, the pre-image is like inside of the image, and it didn't happen on the other one? Like, why did this one, the blue one's completely inside the green one, but it didn't happen on the other one? Talk with a neighbor about it. Again, it's okay if you're not sure, but it's about where the center of the dilation is located. When we do these on a graph, where is the center of dilation? The origin, 0, 0. Where is the origin in relation to this pink guy, or excuse me, the thing that I highlighted in pink, inside it or outside it? Inside it. So it's pretty likely that the blue one's going to be inside. But it didn't happen over here. Isn't the origin on the outside of that guy in that case? So just cool little tricks. Awesome. So reflections, rotations, dilations. Real quick, reflections, did they stay same size, same shape? Translations, same size, same shape? Dilations, same size, same shape? Kind of the point. Yeah, they are definitely the same shape, though, but not the same size. Do you remember what those are called? Starts with an S. Similar figures. Cool. Our homework is on My Open Math. If you would go to your computer and on Canvas, click the link for 9-1. That's where our homework is today.